In this video, we're going to talk about proofs, and the specific example that is in this video is segment congruence, but I just want to take a minute to kind of talk about proofs. So in math, and specifically in geometry, we learn about how to do a mathematical proof. So basically what we're doing is we're making some sort of statement or some sort of sentence, and then we have to justify that it's true. So what that means is everything that I say, I have to give a reason why I can say that it's true. And a lot of students always ask, well, when am I ever going to use this again in real life? When am I ever going to have to prove that triangles are congruent or segments are congruent? And the real answer is you're probably never going to have to do it again unless you become a math teacher or go into like some sort of mathematical research or, deep engineering field. But it teaches you logic. And here's what I want you to think about. Let's just say when you grow up, your job that you get, your boss gives you this task to complete and says, okay, Joe, I have this problem and I need you to come up with a solution. Here you go. And he gives you some stuff. Here's the problem, and then find an answer. So your job is going to go and have to figure out what your answer is. So you come up with this awesome solution and you go, hey boss, I figured it out. And he goes, great, what did you do? You can't just go, well, I figured it out. He's going to want to know, or she's going to want to know, what did you do in order to figure it out? So you can say, well, I did this because of this. And then I did this because of this. And that's what a proof teaches you. It's how to logically think through a process. So, that's kind of what I'm talking about here is I can say that this is true because of this reason. And we say that this is true is called a statement, this thing that you're saying, and because of this reason would be the reason that it is true. So for segment proofs, I went ahead and I made a giant list of reasons of things that you would use in your proof, and I kind of went through and explained them. So I'm going to go through each one. And then I'm going to kind of shrink down the screen. So if you want, you can like stop and take a screenshot of or pause the video and write down all of these. It might help you remember what they mean, just so that it gives you like your word bank, so to say, of what you can choose from. We'll go and talk about the steps here shortly, but we're going to focus on the reasons. So the first one is given. Okay, so given is going to be the information that they give you in the, oops, I spelled beginning wrong. Let's try that again. In the beginning of the problem. And it will literally say given, and then it will just tell you something. And that's going to be the information that's the given. And if you take it from the given, that's what you use as your reason in the proof. The next reason you can look at is what we call algebra. Some books call it simplifying. Some say combining like terms. Basically, when you're using some sort of simplification or combining like terms process in your proof, the reason would be algebra, like I said, or simplifying or combining like terms. It depends on what each textbook uses. They're all a little bit different. Reflexive property says something is equal to itself. And I like to remember this by thinking of my reflection in a mirror. In a mirror, I see my reflection or I see myself. So the reflexive property is going to just say something equals itself, like, well, segment AB is equal to segment AB, or measure of angle 1 equals measure of angle 1. Just whatever it is equals itself. The symmetric property says I'm going to take something and I'm going to flip it around the equals. So if I said x equals 5 and then I changed it to 5 equals x, I can do that by the symmetric property. The transitive property tells a story. So, and the middle stuff is going to cancel out. So you can think of like, if I wake up in the morning, then I brush my teeth. If I brush my teeth, then I brush my hair. If I brush my hair, then I get dressed. If I get dressed, then I'm ready for school. So all the middle stuff cancels out. So your final conclusion would be, if I wake up in the morning, then I am ready for school. All this middle stuff goes, whoops, this stuff all would go away. That's the transitive property. Okay, addition and subtraction property, that's going to be when you're adding or subtracting something to both sides. So like in if you were solving an equation, right, like if you had x plus 4 is equal to 10, and you would subtract 4 from both sides, this part right here, from here to here, your next step, would be addition or subtraction property because you subtracted from both sides. Multiplication and division properties, it's the same concept, except this time you're either multiplying or dividing. So say I had something like 4w equals 12. I divide by 4, and my answer is w equals 3 from here to here. I used multiplication and division properties because I divided both sides by 4. Substitution property is when I'm plugging in a value. So if I have something like, well, 4 plus x is equal to y, but I'm telling you x equals 5, wherever I have an x, I replace it with a 5. That's called substitution. Definition of congruent segments basically says that if you have a segment that's congruent, it also means it's equal. So you write it out like this. You say like segment AB, this symbol right here means congruent, is congruent to, segment AB, but it also means I could say that my lengths are equal. Notice the difference here. I have a line segment over top and I use the congruent symbol. When I don't have a line segment above my letters, I use an equal symbol. This represents the distance or the length, and this represents the actual segment. Segment addition property says that if I have this big segment here and I split it up into two pieces, I have two smaller sections. So let's just say, for example, this green section is 5 and this orange section is 10. We know that the whole thing is going to be 15. Why? Because 5 plus 10 is equal to 15. So I like to think of it as my small segment plus my small segment is equal to my big segment. Our last two, we have definition of congruent angles. Okay, same concept as congruent segments, except it just shows that angles are either equal or congruent. So if I'm talking about angles being equal, I have this M out in front that stands for the measure. It gives you the actual measurement of your angle. So the measure of angle 1 equals the measure of angle 3. Or if I'm just talking about the angles themselves, I don't have this M and I just say angle 1 is congruent to angle 3. And then the angle addition property is kind of like the segment addition property, except it really just has to do with angles. So if I tell you I have this big angle right here, that's 100 degrees, and that this green part is 40 and this blue part is 60, well, that makes sense because 40 plus 60 is equal to 100. So I like to think of it the same way as my small segment plus my small segment is equal to my big segment. Okay, so those are all of your reasons that we're going to use. So I'm going to kind of flip this around like this. I'm going to shrink this down really small. And this would be a really good time to take a screenshot so that you can kind of see all your choices and know what you have to choose from. Okay. The other thing I wanted to talk about is steps. The hardest part about a proof is they only give you a given and then they give you, and I want you to prove this is true. And there is no real formula, there's no PEMDAS, there's no real way how to do a proof. So this is what, over the years that I've been doing this is what I've come up to be the best method on how to execute a proof. You always want to start with the given, okay? Whatever given they give you, write it down first. So you should always at least get some points on your test if you can write down the information that's given. And then this next step here says extract. So what that means is sometimes in the given they're gonna tell you some information that you can say, oh, well, this information means this. You always want to ask yourself the question, what does this mean? If you can ask yourself the question, what does this mean? And then you can answer that question. That's what we're doing by extracting information. You want to do that until you can't answer that question anymore. There's nothing else you can say. Okay, then we're going to look at the picture that they give us. Most of the time you get a picture in your proof. Then I'm going to look at my picture and say, what information does my picture tell me? And then I'm going to write that information down. And then I'm going to, again, extract information from my picture. Well, if this is true, then, oh, I know, what does that mean? Well, that means this is true. Well, what does that mean? That means this is true. You want to extract the information as much as possible. Okay, now you've run out of extractions. What you're going to do now is you're going to combine steps from your given and your extractions and your picture and extractions. And you're going to start combining steps together until you get to the final thing you're trying to prove. Okay, that's a lot of talking, so let's just do one example so that you can kind of get an idea of how this works. Okay, so here's my example. I happen to know this is I'm going to do this proof in 6 steps, and just to save some time, I wrote that out. But typically, they're just going to give you this top part right here, like here's your given, here's your picture, and then we're going to do what's called a 2-column proof that has your statements and your reasons, and that's all they're going to give you. Okay, so first thing we do is we start out with our given. So I'm going to take this information here, and I'm going to write it down in my first step. So I'm going to say that BD is equal to CE, and my reason is given. Okay. I'm also going to use my picture to draw this information in. So they're telling me that BD from here to here is equal to CE, which is here to here. So I'm talking this segment here and this segment here are equal. That's what they're telling me. Okay. What can I extract from that information? Well, it doesn't really, this specific thing doesn't tell me anything, but when I look at my picture, since I just highlighted that part green, I happen to see a small plus a small equals a big. So I'm going to write that down. I'm going to say that BC plus CD is equal to BD. Now, what tells me small plus small equals big? The segment addition property, and I just use abbreviations. Segment addition property. Okay. All right. What does that mean? Well, I can't really take any more information from there, but I also happen to notice that when I looked at this orange segment, it's the same thing. I also have another small plus small equals big. So I'm going to write this down too. I'm going to say that CD plus DE is equal to CE. And that's also the segment addition property or postulate. Some books call it a postulate because I'm taking, again, my small segment, CD, plus my other small segment, DE, equals my whole big segment. So I'm going to write that down again. So this is segment addition property. Okay, so what does that mean? Well, that doesn't directly tell me anything. Okay, so now I've taken all my information from my given. I have nothing to extract. I've taken all my information from my pictures. I have nothing to extract. So I have to start combining things together. So in the beginning, they told me, right, that this green segment and this orange segment are equal. Okay, so I know that, that BD is equal to BC plus CD. So I could substitute that in here because I know that those are equal. They also tell me that CE, we already figured out that that's equal to small plus small equals big. So I can substitute that in here. So I can actually write that BC plus CD equals CD plus DE. So what did I do? I used substitution. Okay. Now, what am I even trying to prove, by the way? I'm trying to prove that BC, so this guy, is equal to DE. And I happen to notice that I have BC and DE here. I also happen to notice that I have both sides have a CD on them. So this is where I'm going to say, all right, if both the sides have a CD, I'm going to have to write this next step so I can intentionally combine it with my last one. I'm going to write that CD is equal to CD, and something equals itself by the reflexive property. And here's why I do that, because now I just created an equation for myself. I'm going to combine together my steps. So I'm going to say in step 4, if I subtract step 5, these are going to disappear. Just like if I was, subtracting a number from both sides. I can do it with segments too. So now I end up with BC equals DE. And that's what I'm trying to prove. Okay, but how did I get to step 6? What reasoning did I do? Well, I combined steps 4 and 5 and I subtracted CD from both sides. So I used the addition and subtraction properties. Okay, some books you would just say subtraction property of equality. Some are super specific, but some books just want you to say, well, I used addition or subtraction and I subtracted something from both sides. So there's your completed proof. So it kind of went through all the steps about how I write my given and then I extract information. I look in my picture, write down what I know, extract information, and now I'm going to combine some steps together to finalize my proof. I know this is a lot. It can be really tricky. You will get better at them the more that you practice, but if you have any questions, let me know. Good luck.